Hi, in the section 7.2, the Kruskal-Wallis test. So remember that for t-test, we have some test which corresponds to t-test but more flexible. That is the Wilcoxon signed rank test and Wilcoxon the rank sum test for two-sample t-test. So t-test is based on the normal errors, but the Wilcoxon test can be applied for any distribution. So generally, the test requires the specific distribution, so very restrictive in terms of assumptions. So we have the more general test, but that is a little it has a lower power than the t-test. So ANOVA also have the similar version. So that is Kruskal-Wallis test. So ANOVA assumes that the xij is alpha I plus epsilon ij, and epsilon ij is normal. But Kruskal-Wallis test does not assume any distributional assumption. Actually, we have some small assumptions, but the very weak assumptions. So we discussed this Kruskal-Wallis test in this video. So the Kruskal-Wallis test can test the difference between groups with only assuming the epsilon ij's are independent and identically distributed and continuous. But we don't have any assumption on median, actually even mean, and no distributional assumption. It doesn't have to be symmetric. And idea is similar to Spearman's rule. So we replace xij by rank of xij. Then even if the epsilon ij is very skewed, it does not affect the result. So since we only use the rank information. So we lose some information by making it a rank, but it becomes more general and robust against the different distributions. And suppose alpha r sub ij is the rank of xij, then the test statistic is here. So it's a little bit different from the ANOVA, but basically this is the sum of the squared residual between groups. So the numerator is the sum of squared between groups. And the denominator is rather constant here. So you can see that this is the rank alpha rij minus the r bar dot. So r bar dot is the overall mean of r, but rij is rank. So if we have, for example, the 10 observations in total, so this is 1 to 10. And the average is 5.5. So it's always fixed. So this is almost just a fixed number, just a function of n, the entire sample size. So, and this is also some constant. So basically, this is the summation of these terms. And we have the g terms here. And we calculate, okay, so this is the ice group, the mean of ice group minus the overall mean. So we lose the 1 degrees of freedom by using this, the sample mean of overall, group. So g minus 1 is degrees of freedom. So it's so-called the chi-square test. And this follows chi-square, the g minus 1. And this is approximation, so it does not follow exactly chi-square distribution, but approximately. So this follows chi-square distribution. So I think this is the old result from the 1950s, and some approximation was done. So we reject null hypothesis of all groups are the same when this test statistic is large enough. So the numerator is the sum of square between groups. So if this is large, then groups are different. So we reject null hypothesis. So if chi-square distribution is like this, then we reject if chi-square value is large enough. so large chi-square value, this is the rejection region. So this threshold is chi-square of 1 minus alpha. So this is area alpha. So this is how to do the Kruskal-Wallis test. Okay, an example. So we have 3 groups. So this is just a kind of toy example. So only 3 observations in the first group, and second group 2 observations, and the third group the 2 observations. And okay, so we cannot really see the distribution with only 7 observations, but assume that this isn't necessarily normal distribution, and we calculate the rank. Then this is smallest, so rank 1. And the next smallest one is maybe here, so rank 2, and so on. So we can order this, and 1, 2, 3, 4, 5, 6, 7. So we can determine all ranks. Then we can calculate the average ranks. So 7, 6, 4 overall, the 17 in total, divided by 3. So average is 5.63. Second group, 5 and 2. So average is 3.5. 3 and 1, average is 2. And overall average is always 4 because we have 7 observations. And the statistic K is, so this constant and constant here. So sum of the I minus 4 square, I is equal to 1 to 7 is always 28. And the times 7 minus 1, and this is the sample size minus 1. So that's anyway constant. And the main part is the numerator. So we have the sample size here, 322. So this is the sample size, the 322. Then the R1 bar minus R dot bar square, and the same thing for the second and third group. And in total, this becomes 3.6. And this follows the chi-square distribution with DF2 because we have 3 groups, so 3 minus 1, 2. So on average, this should be 2, but now the 3.6. So possibly it's marginally significant, but only 7 observations. So probably we do not reject null hypothesis. And yeah, if you use the chi-square function, you can get the p-value. But another way to do that is using the Kruskal.test function. And the code is the variable tilde and the group. So here group indicates which group each observation is in. Then the chi-square value is reported, and df degrees of freedom for chi-square is 2, and p-value is 0.1647. So it's not significant because it's larger than 0.05 if we use 5% significance level. Or you can calculate everything from scratch. We have 7 observations, and we have the data, so we calculate the rank of the data, and we calculate the overall mean, and also we calculate the group mean. Then you can plug in numbers in the formula for Kruskal-Wallis test. Then you can get the same number, and you can also calculate the p-value by using the probability of chi-square function. Yeah, some examples probably will be asked in the homework. And the notion of non-parametric method. So we have studied t-test and also the Wilcoxon signed rank test. And also, okay, so this is 1 sample t-test, and the 2 sample t-test that is corresponding to Wilcoxon rank sum test. And the ANOVA corresponds to Kruskal-Wallis test. So these 2 groups are different. So we say the first group as parametric method and second group as non-parametric method. So the first group is based on the parametric assumption, such as, for example, yeah. So one sample t-test, the mean is mu, and the standard deviation is sigma, and everything else is determined by the distributional assumption. So observations follow a normal distribution. But here, Wilcoxon signed rank test, we don't have any distributional assumption. So we say the first group as parametric and the second group as non-parametric methods. Okay, so this is the end of 7.2.